The value of the second ionization energy of calcium is 1150 kilojoules per mole. Which equation correctly represents this statement? Okay. First of all, second ionization energy. We will have to start with calcium positive because it is second ionization energy. If we start from calcium neutral atom, that will be its first ionization energy. So search for calcium positive. Calcium positive, we can see it in choice B and in choice C. So these are our focus. The second is look at the choice B. Electron being removed and the ionization energy is 1150 kilojoules per mole. That is positive. In choice C, the ionization energy is minus 1150 kilojoules per mole. That is negative. Remember, ionization energy is endothermic, means heat will be absorbed in this change. So we will get a positive sign. So positive sign is in choice B. This is the correct choice. The concept in this question was that search for second ionization energy. So we will start from an cation having already a positive charge. And the second was that ionization energy is endothermic process. So we will search for a positive value. So here is the positive value. Which equation represents the second ionization energy of an element X? Again, it is second ionization energy. It means that we will start from X positive charged. So which choice is here? The choice is choice B. Because we are providing the second ionization energy to remove the second electron. This is why the X should have a positive charge from the first. So it has a positive charge and we are removing second electron. So we are getting two positive charge on it. And the atom should be in gaseous form. That is the rule for enthalpy, ionization enthalpy. From which particle is the removal of an electron the most difficult? We are given chloride, fluoride, potassium ion, and sodium ion. Many factors control the ionization energy or the removal of electron, but over here we will focus on size and then upon the nuclear charge. If we look at the potassium and sodium, they fall in the same group of periodic table. Sodium is above and potassium is below it. In fluoride and chloride, fluorine and chlorine fall in the same group and they are shown as. Sodium has smaller atomic size, potassium has larger atomic size. Over here, fluorine has smaller atomic size but much smaller than sodium, and chlorine has smaller atomic size than potassium but larger than fluorine. So this was for size. The next we have a positive charge. Sodium has a positive charge and potassium has a positive charge. Chloride has a negative charge and fluoride has a negative charge. In case of cation, the size further decreases. In the case of anion, the size increases. It means that sodium atom has a larger size, and when it becomes sodium positive, it has a smaller size. So sodium has a smaller size. But again, potassium has a larger size compared to sodium, and compared to its atomic form, it is smaller. Here, fluoride has a larger size because of this negative charge. Chloride has a larger size too, but more larger than fluoride. Ionization energy is inversely related to atomic size or ionic size. The bigger the size, the smaller the ionization energy. Next, ionization energy is directly proportional to charge or nuclear charge. Greater the charge, the greater the ionization energy, and that is mostly a positive charge, not negative. So in all this discussion, sodium has a smaller size, sodium cation has a smaller size, and it has a positive charge on it. So our focus is on cations, sodium and potassium. The next thing, now sodium and potassium both have positive charges, but the charge density on sodium cation is higher than charge density on potassium cation. This is why ionization energy is also directly proportional to charge density. And density is equal to mass per unit volume. When volume increases, density decreases. Over here, potassium has a larger size, so its volume increases and density decreases, while sodium has a smaller. So sodium cation is the correct choice. The first ionization energies of successive elements in the periodic table are represented in the graph. So the graph is given. First ionization energy in kilojoule per mole is on y-axis and the elements are given on the x-axis. Which of these statements about the graph are correct? Okay, which statement is correct or are correct? So let's see. The first they say element B, J, and R are in group 0 of the periodic table. Group 0 is the exists on the far right of the periodic table, which is noble gases. Noble gases have the highest ionization energy. So, because ionization energy increases from left to right in a period, so the highest ionization energy element in a respective period will be that noble gas. So there is, they say, element B. This is element B correspond over here. This is B. The next is element J, which is this one. This is element J. And the third one R. So R is here and it is this one R. These are zero group. So yes, if we say this is the start of a period, this is the end of the period. Again over here, this is the start of a period and this is the end of the period. Start of the period and end of the period. So at each period, we are getting highest ionization energy element and they are noble gases. So statement first is correct. Second statement, atoms of elements D and L contain 2 electrons in their outer shells. Atoms of element D, this is element D over here. The next is element L. Here we can see this is element L. These are element L and D. Means they have 2 electrons in their outer shell. Now they have 2 electrons. We can't take it from the graph. But we know that the first group is alkali metals except hydrogen. This is hydrogen. This is lithium, sorry. This is sodium. Again, it is potassium. Those elements having 2 electrons in their outer shell belongs to group second A. So D and L is following sodium, D is following lithium. So they are members of the second group. So this is correct. Atom of element G and O contain half-filled orbitals. G is this one. This is G element and this is O element. This is O. Half-filled orbital, we remember that when we are going in a period, ionization energy increases. For example, this is for the first element of the period, second element, third element, then fourth element, fifth element, and sixth element, seventh, etc. Sixth, and then you can go just like this. So means that these have half filled, that is nitrogen family. So nitrogen family has these 2 half-filled outer shell, half-filled p orbitals. So these are nitrogen, so means that this statement is also correct. So all the statement given about this graph are correct. The element radon, francium, and radium have consecutive proton number in their periodic table. What is the order of their first ionization energies? Okay, you will be given a data booklet which will help you. Radon is the member of group 8th A. They are noble gases with a proton number of 86. Francium has a proton number of 87 and radium has a proton number of 88. Another thing, radium falls in 6th period of the periodic table, while francium and radium fall in 7th period. First thing, we know that down the periodic table in a group, we get a larger size. It means the radon is in 6th period. It has a smaller size compared to francium and radium. Next thing, francium and radium are in the same period, and as we go from left to right in a period, size decreases. Means francium has a larger size and radium has a smaller size. Now, according to the size, the highest ionization energy is acquired by radon because it has a smaller size compared to these two. So, and another thing, in radon, the electronic configuration is Np6p6. Now, this is a completely filled p subshell. Removal of electron is harder. So, highest ionization energy will be obtained by radon. So, the most endothermic means highest ionization energy, and least endothermic means smallest ionization energy. So, radon, we are getting it in choice A and in choice C. So, these two choices are now in our focus. The other two are neglected. Now, coming towards the francium and radium. Francium has a larger size, radium has a smaller size. The next thing, francium belong to alkali metal and they have Ns1 electronic configuration, while radium belongs to group 2, a alkaline earth metal, and it has Ns2 electronic configuration. The next thing, that Ns1, the removal of electron in easy than in Ns2. So the smallest ionization energy will be acquired by francium. So we are getting the smallest in choice A and in choice B. So from this discussion, our order should be like this, that francium less ionization energy than radium and less ionization energy than radon. So in the middle, we will get radon, which is over here in choice A. So the correct choice is A. The first 7 ionization energies of an element between lithium and neon in the periodic table are as follows. These are those ionization energy values. What is the outer electronic configuration of the element? We are given these choices. First of all, in order to solve this, we will start from lithium that has a proton number of 3 and ends on neon with a proton number of 10. And these are 7 ionization energies. These are given the outer electronic configuration. If we take choice A, there must be 1s2 and then 2s2. So this element has a proton number of 4. Coming toward this, 2s2, 2p1, it has 1s2, 2s2 and 2p1, a proton number of 5. This one has 1s2, 2s2 and 2p4, a proton number of 8, and 2s2, 2p6, that starts from 1s2, 2s2 and 2p6, a proton number of 10. Here we are removing first 7 electrons. This element in choice B has a total of 7 electrons, and the same is in choice A, has no electron, total 7 electrons. So these two choices are kicked out. Now starting from these two, choice C and choice D, look at the values. We are removing the first electron at 1310 kilojoules per mole. The second is at 3390, 5320, and 7450. The fourth one is 11,000. Fifth one is 13,300. And the seventh one is 71,000. It shows that these ionization energies are very close together, and then these two are close together, and it is very high, not closer to this one. Now in choice C we are getting 2s2 and 2p4. In choice D we have 2s2 and 2p6. In choice B, if you see, this is partially filled p subshell. It will give us the first electron easily, and after giving the first electron, its ionization, its electronic configuration will become 2s2 and 2p3. Here, now, if you remove the electron from p, next electron, you will get 2p2. In removing the next electron, you will get 2p1, and then you will get 2p0. P3 is half filled. It is now stable, and we are providing next ionization energy. So ionization energy, this one, the next ionization energy, and the next ionization energy, these ionization energy will be closely related. So this is why if you see over here, these ionization energy are closely related. So means that the element we have to choose is choice C, because from the P4 the first electron will be removed easily, that is removed on 1310 kilojoules, while the second, the next electron, the next and the next, they will be closely related. If we have to start from choice D, in choice D we are getting that it has P6. It is a stable subshell with complete electrons. So in order to remove an electron from it, we will have to provide the first ionization energy much higher, not 310. So the choice over here is C. This ionization energy belongs to this element. Three successive elements in the periodic table have first ionization energies, which have the pattern shown in the diagram. This is the diagram showing the atomic number on x-axis and first ionization energy on the y-axis. What could be the first element of this sequence? Carbon choice A, nitrogen choice B, fluorine choice C, and sodium in choice D. First of all, let's decide the three successive elements. You will be given a data booklet. Three successive elements. Carbon belongs to group 4th A. 5th A, nitrogen is member of it, and 7th A, fluorine is its member, while sodium belongs to the first group but not in the second period. This is the second period going on. Sodium belongs to the third period. This is the first element. Over here, this is lithium. And here you will find neon. And in this period, the last element is argon. So sodium is kicked out from the choices. Now coming towards the decision. This ionization energy X, again in ionization energy mark, and then in ionization energy mark. Now if we decide carbon, nitrogen, and fluorine, from left to right, ionization energy increases. So the highest ionization energy is acquired by fluorine, and in this diagram, this point refers to fluorine. Carbon belongs to fourth group, nitrogen belongs to fifth group. The ionization energy of nitrogen is higher than carbon because nitrogen has P3 half filled P and it has P2 which is partially filled. So half filled subshell is more stable. So the second highest ionization energy will be referred to nitrogen. So this is the second highest ionization energy at this proton number. And the last one that remains is for carbon. So what could be the first element of this sequence? The first element of this sequence is nitrogen in choice B. The first 6 ionization energies of 4 elements A to D are given. Which element is most likely to be in group 4th of the periodic table? And we are given the tabulated values. First of all, look at the valence electronic structure of the group 4th. Group 4th elements are Ns2, Np2. This is their electronic structure for the valence shell. Means when we removing the first electron, element is Ns2, Np2. When we remove the second electron, then the element become Ns2, Np1. When remove the third electron, it will become Ns2, Np0. For the fourth electron, it will become Ns1, Np0. And the fifth will move Ns0, Np0. So these are the successive strategy to remove the electron one by one from the valence shell. Now, the next thing we must have to understand Ns2, Np2. We are removing both the electron from the p subshell. So the first ionization energy and the second ionization energy must be closely related. So look at the value. 494, a 3 digits value, and this one is a 4 digits value. There is a huge difference which is not required because the electron are removing from the p subshell, the same subshell. In the choice B, 736, a 3 digit, and it is 450, a 4 digits. Again, it is a huge difference. Means that these two are not the correct choices. Coming towards choice C and choice D, if you look, there is difference and there is difference. Both the differences are not too much high. So we can consider the yes, both the electron are removing from the p subshell. Now moving to the next. So we accept both these values for the time. Now coming towards the next value, that is second to third ionization energy. If you watch the difference here and the difference here, here should be the difference larger, because now the third electron will be removed from ns2, so the difference should be larger. If we see 2350 and 4610, this difference is larger compared to 2860 and 4590. So this is the larger difference. Means this shows the yes, the electron is being removed from the ns orbital. So choice C is the correct choice for the element that belongs to group 4th of the periodic table. So this was the concept that how we can develop electronic configuration of an element from the given ionization energies. Similarly, if you move over here, and then here, you will get here a huge difference. It means that now the electrons are being removed from a shell, not only subshell, but a shell further closer to the nucleus.